Look, so a warm welcome, everyone, to our third session of Science, Sense and Sensibility. I hope we have a lot of returnees from our previous two sessions. But looking at the registration numbers that we did have coming in, I think we have a lot of newcomers as well, which is awesome. And looks like we're creating a following. My name is Michael Leader, and I'll be your host moderator for this session. So I'm working in regulatory policy and issues management for Bayer Crop Science, looking after scientific capacity building efforts, regulatory harmonization efforts in the Asia region. I'm a molecular biologist by training and have a law degree and have been working with Bayer now for 15 years, but was working in government before that. So I've been, my unit has really created this particular initiative. And what we've tried to do is really wanting to, I guess, develop a platform to discuss concerns students may have about agricultural innovation with experts, right, on the line, because there is a lot of misinformation and, dare I say it, even disinformation out there. And it's sometimes hard to work in this sector when family and consumers are hearing some of this and potentially asking questions and making it difficult sometimes. And hopefully with this talking to experts we can try and debust some of those myths in a fun way, right? Our first two sessions focused on the future of agriculture. So we talked on regenerative ag, precision techniques, and genome editing. And the second one helped debunk common myths about genetically modified organisms. But today we're focusing on pesticides, and we have three great speakers, one from academia, one from the farm, and the last one from the private sector, and to talk about the common misconceptions they hear about crop protection products in their everyday work. Each speaker will give a short talk for about 10-15 minutes. We'll allow 1 to 2 questions after each presentation if there's time. You can either raise your hand or post the question in the chat. But don't hesitate to post questions in the chat as we go along too, because there will hopefully be some time for general Q&A at the end. We do encourage questions, and a reminder that as for our previous sessions, we'll be selecting a few of the most engaged audience members to see if they would like a one-on-one mentorship sessions with a Bayer expert afterwards as well, just to talk about things and to see what it's like to work and learn here in Bayer. So. And also a reminder that we will provide online certificates for this event as well. So I would encourage you to complete the post-session survey if you would like to see one of these certificates. But enough from me, though. You want to hear from the experts, I'm sure. So let's go into that. Our first speaker is Dr. Christopher Preston. He's a professor of weed management at the University of Adelaide, where he works on understanding and management of herbicide resistance in weeds. He has also worked in risk assessment for herbicide-tolerant crop use in agricultural systems. He has considerable experience of herbicide behaviour in plants and animals and has spoken at significant conferences on weed science as well. He's published more than 180 peer-reviewed journal articles, so I think he's very well positioned to provide us information about pesticides and myths. So without further ado, I'll hand it over to Chris. Thank you very much, Professor Preston.
Thank you, Michael. And what I want to do in this short talk is to just touch on a few of the facts about pesticides and a few of the myths about pesticides. And I'm going to finish off by showing some examples of things that come up around pesticides that aren't true and how you can work out whether the claims are true or not. So if you can just move to the next slide for me, please. Okay, so some clear facts about pesticides, one of which is, if we're going to define a pesticide, it's a substance that we deliberately place in the environment to kill or control pests. And this actually has some implications about what pesticides might do, because pesticides are killing or controlling pests, and that means that many pesticides can have off-target effects on humans or indeed other species. One of the things that I do spend a lot of time talking about is pesticide residues in food. And I want to impress upon you that residues in food that are below the maximum residue limit are in fact not a danger. I'll talk briefly about why that is, but you'll get a lot more information on that later. But I think it's an important thing to remember. Thanks, Effie. You're moving to the next slide, Effie. Excellent. Thank you. So pesticide regulation aims to protect users, consumers, and the environment. And there's a lot that goes into pesticide regulation, and you'll hear some more about that later. But I'm just going to focus on one regulatory endpoint to point out really how this works to protect, in this case, consumers. And this is a regulatory endpoint called the acceptable daily intake. In some regulatory systems, it's called something different, but it's essentially the same thing. And one definition, this is the definition used by the Australian regulator, is that the acceptable daily intake is the level of intake of a chemical that can be ingested daily over an entire lifetime without any appreciable risk to health. And the aim of the regulatory environment is to ensure that consumers do not reach the acceptable daily intake, that in fact their consumption of pesticide residues is always below that. Of course, to make sure this happens, following the product label is an essential activity that must be done. Thanks, Effie. Next slide. So one of the things about pesticides that I'm sure that many of you are familiar with is that pesticides are under threat worldwide. And I've only got shown two examples here. And in fact, they're both about glyphosate. And indeed, all the examples I will talk about will be about glyphosate. The people who are wanting to ban pesticides are often creating a whole range of reasons why we should ban pesticides that are not necessarily based on science. And often they will use quite frightening imagery to do this. And I think that the really important thing is to be able to step back from this and ask the question, what is the evidence for these claims? And when we start looking at the evidence for some of these claims from a scientific perspective, we can then decide whether there's anything in that claim and therefore do we have to do something different, or is that a spurious claim? Thanks, Effie. Next slide. One of the features of modern chemistry is that it's now possible to measure very small amounts of pesticides. And people can use these measurements to create fear about pesticides. So this is an article from a newspaper that was headlined, "Disturbing," in quotes, "a weed killer ingredient tied to cancer found in 80% of US urine samples." And the real question here is not so much can we find the pesticide, but is the amount of pesticide we find likely to be harmful? And because our detection techniques have got so good, we are spending a lot of time finding pesticide levels that are not in fact harmful. And this is a good example of this. None of the amounts found in this study were in fact potentially harmful to the people involved. So now I want to talk about some examples that actually come from the literature of how research using pesticides is done incorrectly and therefore creates fear about pesticides. But because it's in the peer-reviewed literature, people outside science thinks that it is correct. So when we come up with these claims, how can we determine whether these claims are useful? So I'm going to show three examples, and I'm going to point out where in these claims you can look at the methodology and the information to determine whether this has actually been a useful test. So this one's talking about effects of glyphosate and Roundup on human placental cells. So these are the cells out of the placenta that joins the baby to the mother. And what they did was that they used concentrations of glyphosate as well as the formulated Roundup at up to 2% of glyphosate in water or Roundup in water. This is the amount that a farmer might put in their spray tank to go and spray weeds. There is absolutely no way that placental cells will ever be exposed to Roundup because it's sprayed onto plants, and they are unlikely to ever be exposed to 2% glyphosate because that's what's in the spray tank and it's not what people are going to end up consuming. So the fact that they had to go to these high concentrations to show any effects means not that glyphosate is dangerous, but in fact, glyphosate is safe because there's no way anybody is ever going to be exposed to these concentrations in isolated cells in a dish. Thanks, Effie. On to the next slide. This is another example. It's talking about the effects of Roundup and glyphosate upon mammalian sperm function and survival. And again, we're looking at what the experimental design here is. And this had two experiments. They used a range of concentrations of glyphosate and of the herbicide Roundup and floated sperm in them. Now, they only found effects from the Roundup, but sperm is never going to meet Roundup because Roundup is sprayed onto plants. It's outside in the environment. People don't ingest Roundup. What they ingest are residues of glyphosate. So again, this research is not showing that there's harm. It's in fact showing that glyphosate is safe, but that's not the way the paper's been written. Last example, thanks, Effie. So this is another example where there's been exposure to both glyphosate and Roundup. And what they did here was they took eggs and they injected them with either glyphosate or with Roundup, and then looked at what happened to the developing embryos in those eggs. And again, there is no way that Roundup is ever going to get inside an egg because, again, it's sprayed on plants in the environment. And the amounts of glyphosate that they had there were way higher than the amount that a person might ever be exposed to in their internal tissues from residues. So once again, we have a paper in the scientific literature where the exposure and concentration of glyphosate they were using is just completely irrelevant to what happens in the real world. These papers turn out to be really quite harmful because they can be shown to reporters who then accept them as being real science. They aren't. They're what I call junk science. And with pesticides, there are lots of examples of this because one of the things that people do is that they'll think, I should measure the effect of a pesticide on something, and they use concentrations that might be in the environment and nothing happens. So they just keep increasing the concentration until they get a result. This is poor science because you can't actually use that result for anything useful. So I'm just going to finish off my talk with my last slide here about, well, so what role should scientists play in pesticide safety? And I think there's a few things that those of us in agricultural science can and should do. One of those is we should focus on farmers. And we should discourage farmers from incorrect use of pesticides. And that might include off-label uses, either in rates or times or conditions they're using them. We might encourage them to use the appropriate personal protective equipment as described on the label, and things like off-target movement. So that might be spray drift, or it might be emptying the containers out into water. We should actually discourage all these practices, because we know from our safety work on pesticides that high concentrations can do things in the environment that we don't want. Low concentrations are generally not going to do that. Secondly, as scientists, we need to follow the best evidence. And this means that if we're thinking about doing experiments with pesticides, we need to use realistic exposure rates and realistic exposure routes. So we need to look at how could somebody be exposed to a pesticide and how much could they be exposed to before we start deciding what concentrations we're going to use in our experiments. And finally, something I think scientists generally are relatively poor at is we need to call out that junk science. We need to point out what I've just pointed out about those papers, about why they are wrong, instead of just ignoring them. Because in this day and age, when most of the scientific literature is becoming freely available on the internet, people who don't have the skill set that those of us in agricultural science have won't know that these is junk science. So we need to be able to tell them. So I'm going to finish up there, Michael, and thanks for listening.
No, thank you very much, Professor. And I really like it. The calling out of the junk science. I think that scientists are getting a little bit more confident in doing that as we're going forward now. But I still think with social media and everything, as we know, these things can move quickly, and not facts can move, or non-facts can move very, very quickly. So appreciate that there was a call for that, and the students and the people working in the business should feel free to be able to call that out as well, and actually looking at that point. So appreciate that. We do have one question in the chat, although it's not necessarily about junk science, but more about creating awareness amongst farmers about using healthier products, I guess, or greener products if they're growing, or more, or less hazardous chemistries. But maybe we can, and if you have a comment on that, or what scientists can do in talking to farmers, that might be good. Otherwise, I'm sure that Dr. Ravi or Mr. Ravi can answer that in a little bit of detail when he speaks as well.
So I think from my perspective, I'm working in a first world developed country where farmers generally have a reasonable level of education, but even so, we still suffer from issues where farmers choose the wrong product for the situation and don't follow the label. So I think that the most important advice you can give to farmers is to make sure they follow the label regardless of what the pesticide is. So even if it is supposedly a safer pesticide, none of these are 100% completely safe at every possible concentration that there is. So following the label is probably your first port of call in terms of getting farmers to do things better.
Thanks, Chris. Yeah, that exactly. All right. Well, I know we're still going through the time now, so we might have to go to the next speaker. Thanks a lot for that, Professor. Our next speaker is actually from Bayer, Dr. Christian Kuester. He received his PhD in freshwater biology from the University of Cologne. He joined Bayer in 2013, and his first 8 years were spent in human safety department, where he was responsible for operator risk assessments. Starting in 2022, he's been working on issues management, regulatory issues management, with his focus now on outreach as well. He's active in a lot of external projects through trade associations like CropLife Europe and CropLife International, but he's also a member of the advisory board of the International Centre of Personal Protective Equipment. and is engaged in projects to improve operator safety globally in collaboration with the Food and Agricultural Organization, the World Health Organization, and global regulators as well. He's going to really focus on some of the safety aspects of Bayer's internal processes and regulations, and on operator risk assessment as well. And he might be able to talk to you about his last name as well, a fun fact about that, but I'll let him talk about that. I'll pass it over to you, Christian. Thank you.
Yeah, thanks a lot, Michael. And yeah, my last name is Kuester, which is actually the janitor of the Catholic Church, but I'm not in church any longer. So, and thanks a lot, Michael, for the introduction, and also Christopher for the introduction, because my talk is really complementary to your one. And I'm always referring if there are, again, articles, okay, residues were found there or there. I always refer then to this famous Linkin Park song. In the end, it doesn't even matter. So it always depends not only on what has been found, so it depends mainly on the amount of residues which are found. And today I would like to talk about a common accusation which I'm also facing a lot when I talk to friends and families, that pesticide companies, and in particular also Bayer, because I work for Bayer, they prioritize profits over safety, and they only care about killing pests and not protecting people or the environment. And I would like to give you some insights what we do internally about this, and again, something what also Mr. Preston said, what is actually the difference between a hazard of a compound and actually also the risk. I would like to directly upfront say that there is, and Mr. Preston also said, that there is never a no-risk scenario. So this is also something. So if you want to have a no-risk scenario, then this is not possible. Yes, then you should stay in bed the entire day. But even there, you can suffer, for example, from something. So. And this is what we have here. This is some kind of ongoing public discussion around crop protection safety. You may have heard about it. So we have annually the Dirty Dozen lists are reports which highlights the residues in food. Then we have concerning operator exposure, in particular in Europe. Then we have articles about poison farmers exposing the myth of pesticide protection. Then you have heard about the bee-harming pesticides, in particular neonics, and so on. And the problem is, or the question is not necessarily if we find something in foods. So as Mr. Preston said, we can nowadays detect traces of traces of traces. So I always make the example that you can measure a droplet in Lake Constance, but I'm not so sure if all of you know how big Lake Constance is. I tried to find a similar lake somewhere in Asia, but I could not find it. So Lake Constance is very big. But the question is, how can we distinguish if a pesticide is safe or not? And if you click, Effie, the next one. So we and also regulators in many regions on the world, we rely on a risk-based approach. And I always use an example. So what does risk-based approach mean? Risk is an equation of hazard times exposure. And I always refer the sun as an example. So on the one hand, you, for example, have the hazard pesticide or the hazard of a pesticide. So you know what it can be done in what it can harm in principle. For example, the sun. If you stay in sun for 12 hours a day, you can get sunburn. And what we have in Bayer and generally to register plant protection products, you have to understand the hazard quite well. So what does it do in principle, even with unrealistic high values? Then you do the exposure assessment, which is the reality check. So what is the exposure of humans? So if we find traces of food or of pesticides in food, and then compare to the hazard, then we can say, okay, is the risk acceptable or not? And in for example, concerning the sun, it is the time. Time is the exposure here. And then we also have so once we do the risk assessment, so we compare the exposure, which can be determined in reality, versus a hazard check. So we can see, okay, under these toxicological thresholds, the risk is acceptable, then we can decide whether a risk can be considered as acceptable or not. And we still have some kind of risk mitigation measures. For example, like Mr. Ravi will also maybe tell afterwards, personal protective equipment is a key element in exposure reduction. So you can wear gloves, C1 garments, so which is a coverall, and in this example in the sun, it is sun cream or an umbrella. If you click on the next slide, I would like to focus first on the hazard evaluation, and here you can see just for human safety. So the same is also true for environmental safety, where we also test effects on bees, earthworm, the microbiome, Daphnia, and so on. So many different kinds of species, mammals, birds, and so on. So this is just what we do in terms of toxicity for humans. So we conduct countless studies. So focusing on different kind of aspects, whether or not the product or the substance is eye irritant, is sensitizing, whether it has effects on kidneys, on the reproduction system. We also test for, of course, for cancerogenicity. We have a look at the hormonal system, respiration, blood, and so on, to at the end have a very good overview what it can do in mammals. So of course you can imagine that we cannot do this in humans. So we have surrogate test systems here, which is in animals. This is the harsh truth, yeah. So to test the toxicity, animal testings are needed, and we usually do this in mouse or rats, partly in dogs, in particular for long-term studies, because we also test for chronic and subchronic exposure, and also in rabbits. And based on the findings which we have there, we can then refer to the human by applying additional factors. If you click on the next one. So when it comes to exposure, it also depends how a pesticide is applied. And some uses, as Mr. Preston said, so we can only measure what is according to the label, or we can only assess risk according to the label. If you directly look on the right-hand side, this is never something which we would support. So you have this balloon application on the right-hand side, where you could see, okay, this might look quite smart, but it's not according to good agricultural practice. So you can imagine that this person there, which is walking in the middle, is highly exposed. We have in the left-hand corner, we have mechanical spraying, for example, airbus, ground boom, or airplane spraying. Also now drone application is becoming more and more popular, in particular in Asia Pacific. And this is actually quite good because this can reduce the exposure of operators significantly when, for example, comparing it to handheld application. If you, for example, have a look at the person applying with this manual boom sprayer in the rice field, there you can imagine that this exposure can be quite high, and drone exposure can significantly reduce it. What we do, or generally do, is we estimate the exposure in these different scenarios. If you say, okay, we have the option, or we have the possibility that a farmer is applying a pesticide in a dense crop field, we are also estimating here the exposure and then compare it again to the hazard. If you click on the next one. At the end, we would say, okay, usually it's up to regulators and to register plant protection products. When it comes to operator safety, unfortunately, not in every country, safety of operators is a high priority. So you can see the countries in green, where we have a working local regulation in place, which assesses consistently the safety of operators to pesticides, and in all the yellow areas, we don't have a frequent risk-based approach. And what about countries that currently do not fulfill these criteria? And I can say what we do in Bayer, and I can also speak on behalf of, I would say, many other companies who do this. If you click on the next one, we have an own regulation in place, or some kind of we are our own regulator. So a person with a project idea, for example, if we would like to develop a new product idea in Bangladesh, for example, they have an idea, and we have an automated tier 1 assessment. So where you enter all your parameters for this new use, for example, the crop, the spraying type, whether it's handheld or whether it's drone application, the application rate, and then we run it, and then we get some kind of traffic light system where we can say, okay, no, sorry, this use is not acceptable because here the exposure exceeds the hazard threshold. Or we can say safe use under certain conditions, for example, certain PPE, which is then a prerequisite on the label. And also, for example, if it's yellow, then we have to do further refinements. This kind of approach, we do it quite transparently. We have published it on our transparency website, and we not only do this for operator safety, we also do this for consumer safety and also for the environment. So we always do, on top of local regulations, always do also some kind of risk assessment here. And based on this, we will either continue with the development or we stop it, or we do extra measures to mitigate exposure. You click on the next one. But sometimes it's quite difficult, but because also what Mr. Preston said, yeah, and we have these kind of, in the middle, these kind of safe use triangle where we say, okay, we all need to work together. So the industry need to provide the studies and safe use. We have regulators in best case who are empowered to make informed decisions. And we also have farmers who should apply the pesticide according to label instruction, because this is at the end the scenario which we assess in risk assessments. The problem is, of course, always that we need to rely on agronomic realities in developing countries, and it is not a global model which we apply. We also have a look at local agronomic conditions, because in Australia, farming conditions might be completely different than, for example, in India. So we also need to learn about it. We need to compile and collect information from different regions. And what is also sometimes critical is that we also need to compare risk versus benefits. So the pest needs to be controlled. Fall armyworm, I think, was one of these questions. They can destroy an entire cornfield within days or weeks. And if there is not a specific pesticide in place, then it's really hard for farmers to control this pest. So this is always also sometimes an ethical question to compare here really product safety and food security. And this is one of the biggest challenges what we sometimes have. Because if you click on the next slide, and I think I need to speed up a little bit. If you click everything to complete this. So this is was one reality check what I have. I met a farmer in India who was renting a spinach field. It's 1/2 hectare. And this little bug there on the right-hand side was killing all his spinach, and this was his only income. And he used actually a product which was not registered. So it's not a Bayer product; it was from another company. And I told him, so you cannot use this here. This is not according to label. So this is an off-label use. And he said, if I don't do this, then I don't have anything to sell on the local market. So this is also something which we at some point in time have to consider. And this is also the most ethical challenge, this kind of risk-benefit analysis. And with this, I would like to, if you click on the last one, I'd like to thank you for your attention. And I hope that you now understand that actually the myth that pesticide industry does not care about safety is not true. So I hope that this myth is busted. So the fact is actually that we conduct countless of safety studies, and it depends sometimes more than 10 years to develop a new pesticide, because everything needs to be checked. And in addition, we also, at least Bayer, we also apply internal safety standards on top of local regulation, because for us, safety is a priority over profit. Thanks a lot.
No, thanks, Christian. And I think you're spot on there. And I think that you're right. That did blend well with what Professor Preston also said, that the important thing about label use as well, if you want to get to the farmers and where the reality of what's happening and what they need, and the benefits of being able to use these on farm, is something that we need to try and get them to understand the label part as well. But I think you definitely showed our safety part as well. Are there any questions? Because I don't see any in the chat. Please, I've got time for one question now, if anybody wants to raise their hand. And apologies for my voice at the moment.
But you can also
don't
send me
see.
a question. You can also send me, I have here this email address, so if you have also urgent topics to discuss, and it can also be very critical questions. So I'm open. I like discussions on this point because it's important to talk about these
And
things.
I just maybe just mention just briefly, if no one is putting their hand up, with how much, we do get a red light quite a bit. A lot of stuff doesn't go forward because of the safety standards, right, Christian? It's not like everything goes through. Like actually probably 90% of that stuff is not going through because of that. So did you want to comment quickly on that?
Yeah, so we have in our development, I would say so there is a high throughput screening of AIs also in early tox studies, and many substances will not make it. So we will only focus at the end maybe 1 or 2 in a million substances which will make it through the entire process. And of course, this is something which is also, I think, important to emphasize, that, as Michael said, more than 90%, I think even 99% of they will not make it. And some substances even at the very last moment, because then at the very end, the chronic studies will be conducted. And there you can sometimes also see effects which we haven't seen in earlier studies. So that this is, of course, sometimes frustrating, but for us, it's a no-brainer to stop then also these kind of projects.
No, thanks, Christian. That's exactly the point I wanted to make. So you had the better stats. So that's really good. Thanks for that presentation. And I think it's great that we've done those ones. And now we're going to hear from a farmer as well on how these things do benefit them. What I will do is introduce Mr. Ravi now. And let him speak and on his experience as well. He's a third-generation farmer with over 38 years of experience in rice, cotton, and pulse cultivation. He currently serves as a director in the Global Farmer Network and as National Vice President of the United Farmers Empowerment Initiative in India. He's also a member of the World Economic Forum's Transformation Leaders Network and the state chairman of the Farmers Cell. He's a strong advocate for using technology the right way to improve farm productivity through sustainable methods, including farm mechanization, artificial intelligence, genetically engineered crops, crop protection products. He's been and is a significant award honoree as well as Best Farmer Awards, Innovative Rice Farmer Awards by the Indian Institute of Rice Research, and a number of others as well. Dr. Abe, it's a pleasure to have you presenting today, and I'll give you the floor.
Good afternoon, everyone. Am I audible? Yeah.
Yes, you are. Yeah, thank you.
Yeah. Good afternoon. At the outset, I would like to thank Science, Sense and Sensibility for giving this opportunity. Normally, farmers' voice is not normally heard, but I'm really happy that I have a lot of agriculture students, graduates, students in this meeting. I will try to share my 38 years of experience in about 12 to 15 minutes. It is more challenging than the problems we face in the farm front. So right from the day we domesticated farming, there has been constant endeavor to increase yield. So be it seed, better agricultural practices. So for generations we have been doing that, and yield is reduced by 2 important factors. So from the farmer's perspective, I'm just sharing it. I don't have a PowerPoint presentation. I'm just speaking out from my heart. So this is affected by these biotic and abiotic stress factors. Biotic stress factors like pest, disease, and weed. Abiotic stress factors like heat waves, then submergence, and so on. So as an Indian, we have few Indian participants in this meeting. They know about this green revolution. The pre-green revolution era, we were practicing by default. We were practicing only the traditional farming practices, and we had only traditional varieties. But it couldn't feed even 50% of the present population. Our present population is 1.45 billion population. Even for that, to feed that for 60 crore population, we had to import food from United States under PL 480. That was the situation. thanks to our scientists and breeders and extension workers, and last but not the least, our farmers, we created history. Now we are not only self-sufficient. Now we face different kind of challenge these days. So the population keeps increasing at an alarming rate. The land area keeps reducing. The water resources are depleting, and above all that, the impact of climate change is certainly threatening us. It has adverse impact, though it affects all sectors of the society. Farm sector is most affected by this climate change. So with these constraints, we have to produce more from fewer resources. We must leave no stone unturned in producing more with the given resource. So whatever technology we follow, it should be environmentally sustainable and economically viable. We must create an ideal condition for the plant to perform. It is something like having an ideal road condition for the motor vehicle to give more mileage. So we must create a better environment for the plant to perform. We must adopt and adapt all the latest technology so that our yield gets improved. For instance, coming back to the main subject, that is pest. So pest damage, it is weed menace is the most damaging factor. The factor that damages more on our yield, and the pest accounts for about 25 to 35%. In some cases, so I'm a rice farmer. In some cases, in rice, for instance, brown plant hopper and earhead bug, they devastate our crop. They inflict about 60% damage. So we use different kinds of technologies, and gone are the days when we used different chemicals which are harmful, indiscriminate use of chemicals. So those days are gone. We have new generation chemicals. So thanks to the public and the private sector, we have new generation chemicals which are passed through different regulatory procedures. They undergo all rigorous tests before they are being released for use by the farmers. See, actually, we trust science. We trust scientists. We trust our regulators. We rely on our regulators. So these days we have better molecules are available in the market, and we do use them. These are released. So the regulators see to it that they leave little harm to the soil and the environment. So the moment nowadays these chemicals. Nowadays, as soon as the chemical is sprayed, so it gets deactivated. It breaks down. So they don't leave any footprint in the soil, environment footprint in the soil, the soil organisms, or to the human or anything else. See, these chemicals, they are harmful only for the target pest. So they don't harm so this is my personal experience, they don't harm the predator population or any other non-target organisms. So we adopt integrated pest management. So, there is no standalone solution to control pests. We adopt different kinds of strategies. The synergy of all these strategies, they help us in increasing the yield by reducing the pest infestation. So for instance, in IPM, we apply urea in split doses. Instead of applying it in one dose, we divide it. Instead of applying the recommended blanket dose of nitrogen or any other chemicals, fertilizers, we split it into several doses. So that we reduce the vegetative. The vegetative growth is evenly spread, and we have to maintain weed-free field, because weeds not only compete with the plant for nutrition, water, and sunlight, they also act as a alternative host for pest and disease-causing pathogens. And we do this crop rotation. Instead of going for this monocropping, we keep rotating. After a rice crop, I go for cotton or pulses, so that we break the life cycle of the insect. these are some of the technologies, farming practices we adopt, and we use these pheromones, light trap, color trap, and so on. I use this nuclear polyhedrosis virus to inflict some kind of disease for the pest that is damaging our crop. And we use these egg parasitoids, Trichogramma chylonis, to control this stem borer in rice and borer in sugarcane. So these egg parasitoids we use, and we install bird patch all over the field so that birds sit on these patches and prey on the moths. And we before sowing, we sit together. Farmers in a particular village, in our village, we sit together and decide to grow a particular crop. So instead of different kinds of crops, that means that particular crop would be affected. If person is isolated, then that particular crop would be affected by the pest. So the spread, the pest attack will be spread all over, and there won't be much harm to the individual farmer. And last but not the least, the chemical intervention, we cannot do away with the chemical thing. So we use a lot of these safe chemicals. These days, chemicals, as I said earlier, chemicals are safer to use. We use these chemicals, and we correct dose we have to spray. We are spraying, and by using these artificial intelligence gadgets, its mobile apps are available. We determine what is the chemical that has to be, what is the pest that is, whether it has crossed this economic threshold level. Accordingly, we spray the relevant pesticide. And one thing, another important factor for controlling these pests is seed. So nowadays, seeds are treated with some kind of chemicals. For instance, cotton, maize, and vegetables. They are coated with this imidacloprid. They take care of the sucking pest. So some 15 years back, I thought, I'm also a grower of pulse crop. So in my pulse crop, I noticed a lot of these yellow mosaic virus. I thought, why not I treat my black gram and green gram seed with these imidacloprid so that I address the problem of this whitefly. Whitefly is the vector for spreading this yellow mosaic virus. It is really unbelievable. So, none of my pulse crop was affected by this yellow mosaic virus, whereas the person untreated field of my, my farmer friend, every alternate crop was affected by this yellow mosaic virus. So these are some of the interventions. And molecular markers technology that we are, these days we get this. Even public institutes and Indian Council of Agriculture Research, they have released some of the molecular marker-resistant rice varieties, which has inbuilt resistance against brown plant hopper and bacterial leaf blight and the bacterial sheath blight and blast and so on. So we use these molecular marker-resistant seeds, and I cannot, being a cotton farmer, I cannot resist talking about this tea cotton. There is a lot of false information, misinformation about this BT cotton. So I have been growing cotton from 1985. I have been growing cotton. So those days, I used to spend most of my 60% of my cost of cultivation was only to control these bollworms. Those days, 56% of the total pesticide sale was only to control the bollworms. Now, ever since I started growing BT cotton, I refrained from spraying any kind of insecticide, which ultimately, protects our non-target insects. So, though this BT cotton Basil thuringiensis is meant to control the bollworms alone, it is not meant to address the problem of sucking pests. So my personal observation is, in my cotton field, since I refrain from spraying any insecticide, the insect predators like beetle, rhizova, and dragonflies, they are not affected. Honeybees, they are not affected, and they to an extent they take care of the sucking pests like Jassy, Daphid, and so on. So on need-based basis, spray, we resort to spraying some kind of insecticide to control sucking pests. So I can talk more on GM crop. There are a lot of false information and falsehood about this technology. And so earlier, prior to 2002, I used this Bacillus thuringiensis spray formulation. I really wonder why this. Why the people who are apprehensive about this BT cotton say they don't object to the use of these Bacillus thuringiensis in organic farming. So they are using this Bacillus thuringiensis. So if it is really harmful for the other soil organism, how come there are so much of except this Bacillus thuringiensis, no other organism would survive in the soil. The very fact that they go this is not harmful. See, likewise, they have spread a lot of misinformation. Of course, this I know I don't want to deviate from my topic. And again, we use this. The organic farm. They use this pyrethrin extract from this. I have this. We call it. From the pyrethrin, the synthetic version is pyrethroid. So they use it to be. In Tamil, we call it Chevandipu. So chrysanthemum is the botanical name. I suppose I'm not pronouncing it wrongly. So we use this. So this is nothing but synthetic pyrethroid. So nothing but pyrethroid. See, I do not know. So this is being used by these organic farmers. Then there is say that organic farming, they don't use any insecticide. These are all insecticides. Even acidarytin is an insecticide. It is produced from this neem-based neem-based product. So in order to break the resistance of insects against this pesticide, we have to do this crop rotation. We have to follow this integrated pest management. All such things we have to do so that we break the cycle of this. Instead of relying on a particular chemical, we keep rotating in different kinds of things. And integrated pest management, if we follow, this crop rotation, certainly we can break the resistance developed by these insects. And for cotton, we used to sow this refugia around our field.
Mr. Ravi, we might, thank you. We've only got 5 minutes left, so I might stop there because we've got a couple of questions as well, if that's okay, to share, because I want to make sure we get to the questions as well. But I appreciate that you can see that the farmers, the myth that you've busted today is quite clearly that farmers don't want to use pesticides and are being forced to use pesticides by unscrupulous companies, and that they don't need it to make sure that they can deliver food for people and families to eat. And you clearly have demonstrated a passion, and clearly that farmers actually know how to use them and want them, and that they couldn't really focus without those technologies coming to it. So I appreciate that. And I might just go to this question, if that's all right. And it says that it's in the chat, so hopefully the three of you can see that. But most local farmers do believe that inhalation of pesticides as you consume milk, but apparently milk accelerates the dilution of the active ingredient. I guess they're looking for other healthy remedies. And Christian, you put your hand up. Maybe you probably had this kind of question before, but I think that's an interesting topic to start talking about, those kind of things and what happens with that kind of poisoning thing.
Yeah, usually the exposure to inhalation or via the inhalation route can be considered negligible if it's, for example, not a powder formulation which you use. So the main route of exposure is dermal exposure. So it's therefore always important to protect your skin. Wear a coverall, which is quite thick. Wear gloves during mixing, loading. I've never heard about consuming milk will reduce or even accelerate something. And also ingesting activated charcoal, I think, is nothing which I would recommend. Because
there are probably things that are out there in the fields that people are talking about maybe as well. Yeah, it's good.
Best way is really to prevent exposure, and as I said, wear proper personal protective equipment, a mask if you have a powder formulation, gloves, and chemical resistant, or not chemical resistant, but C1 coverall, which is a normal working coverall. So no thin, not just one layer of clothing, a little bit thicker.
I might, if you don't mind me adding to that,
Yeah,
Michael.
no, please
please
do, and then I'll go to Mr. Ravi after that. But yeah, go. Chris.
I think in terms of inhalation, there is inhalation issues with mixing, but if people are hand spraying, there's potential to get inhalation of the product, and the only way to fix that is to wear a mask. So that, and they don't have to be, for many of the pesticides we're using, they don't have to be terribly sophisticated masks. And we've had lots of, masks we've been wearing for COVID. I wouldn't go for a cloth one, but, wear a proper mask, and you don't, for most of the pesticides you're using, you won't have an issue.
Yeah.
Thanks, Mr. Ravi. Did you want to add anything to quickly?
Yeah. Actually, I have shared a video with FA. So the Institute of Stem Cell Science and Regenerative Medicine, which is a government body, government institute, they have developed a fabric which deactivates the chemicals, pesticide. So we use this personal protective equipment. So I have sent a video also. So this is, this uses the cotton fabric. So whether it is organophosphates or pyrethroids or carbamates, it deactivates everything. And we do use, this recently introduced by this Institute of Stem Cells in Bangalore. I am using it. They sent a sample to me. I am using it, and it has been. If time permits, she can, play that small 20-second video.
No, it's amazing on what innovation can do. We'll maybe get a video, but we only have a minute less, and I did want to, you mentioned this, and I did want to get on to this other question as well, because just that there were 2 or 3 different questions that we got in advance from registrants about, and Mr. Ravi, you did touch on this, but maybe I'll go to Professor Preston on the issue of pesticide resistance, right? Or, and the safe use of pesticides, and actually that, we need to actually have efficacy for them. And how do you tackle the issue of weeds becoming resistant? You talk about your glyphosate resistance is one, but there's others as well, obviously. Is there something that you can suggest or provide some comments on quickly?
Well, to be really quick, one of the things Mr. Ravi talked about was crop rotation. And I think that, the advantage of crop rotation allows you to do different things in different crops and to mess up the pests that are causing you problems. Typically, our strategy around pesticide resistance is that you include a range of tactics to control that pest. And they will include some chemical tactics. So we don't go to higher rates. We go to other products that will work, and we add to that other practices that are going to be effective. And that might be things like crop competition. It might be things like planting your crop at a different time. There are a whole range of those practices, and you have to set them up for each one of the pests that you're trying to manage.
I think that was very quick. Thank you. We have got onto time, but I just want to say, are there any last comments or said that I don't see any hands up still, but there still might be 1 or 2 minutes if you want to put your hand up. But otherwise, I might provide do you have a final message or something you want to leave with the folk on the line? I'll go to Christian first, maybe, after hearing and seeing the questions, and but. I'm hearing that's an excellent session, so that's good. People are signing off. But Christian, any last thoughts or words?
Yeah, I would say, I think I would also refer to Mr. Preston, call out junk science if you see something, and maybe also something what industry needs to learn is we need to also improve our communication strategy. We need to transparently also publish our data to also foster trust in the science, what we do. And I think we can only do this in having these kind of sessions, talk to persons, take concerns seriously, and just, talk about
Thanks, Christian. And Chris, any last minute or last sentence to leave people.
So I think one of the things is that we need to treat pesticides with care. You know, we've talked about how safe they are, but they are under pressure from activists around the world, and things that farmers do poorly just gives activists opportunity to highlight poor practice. So we really should be focused on how do we use pesticide in the safest and best possible way.
Thanks, Professor Preston. And Mr. Ravi, you have the last word.
Yeah. So anything that is in excess is certainly, not advisable. For instance, even water, you can consume 1 liter of water, 2 liters of water. What will happen if you consume 4 or 5 liters of water? All your cells in your body would fail, and ultimately, eventually, one would face, serious health-related consequences. So we must use these, chemicals more responsibly and identify the right kind of pesticide or chemical, and we have to apply it the right way. So this is the way, by adopting all these practices, certainly it is going to be very safe.
Thank you very much, Mr. Ravi. I think you made the right point. It's a good way to start. The dose makes the poison, right? Everything can kill you if you take too much stuff on that. Just everything's harmful. So it's a good way to think about things. Thank you, everyone. We've gone over time. Really appreciate everybody staying online and participating in our third session of Science, Sense and Sensibility. And thanks, Effie. There's a link to the event survey. Again, remind you to fill that in if you want to get a certificate for this. And again, look, I'm going to clap. Maybe everyone else has done. Thank you very much to our 3 experts who made the time today to present. Really appreciate your time and effort. And everybody, have a good day. Thank you very much.
Thank you, Michael.
Bye-bye.
Bye-bye.
Thanks, everyone.